Welcome to The Explainer. Today, we're tackling a massive headache in modern AI. You know the drill. You've got a model that seems absolutely brilliant in a chat interface, but the second you ask it to run a real, autonomous workflow in production, things just start breaking. Today, we're going to explore the architectural solution to that exact problem.
Here is the roadmap for how we'll unpack this today. We're going to cover the helpless AI brain, defining the agent harness, how frameworks compare to harnesses, the 6 architectural layers, and finally, the future of autonomy. Let's get right into it.
Section 1. The helpless AI brain. We're going to look at why these models are brilliant, but honestly, kind of useless in the real world.
Let's start with a really painful truth. Raw AI models, your GPT-4s, your Claudes, they are incredibly smart, right? Absolute phenomenal reasoning engines. But they are fundamentally stateless, they're non-deterministic, in isolation, they're functionally helpless. If you've ever watched a super capable model confidently hallucinate a completely fake API endpoint, or just entirely lose track of its original goal halfway through a task, you know exactly what I mean. Upgrading the brain, the model itself, just isn't solving these real-world production nightmares. So what's actually going on here?
Well, Atlan actually published an analysis on this, and get this, a staggering 65% of enterprise AI failures in deployed environments are caused by data layer defects alone. Think about that for a second. It's not that the model isn't smart enough, it's that the environment it's operating in is fundamentally flawed. When a model fails in production, it's usually suffering from context drift, schema misalignment, or state degradation. Basically, it just forgets where it is in the workflow. The intelligence is absolutely there, but the operational reliability, it's entirely missing.
Which brings us to Section 2, defining the agent harness. This is the missing layer that solves this exact problem.
So what is it exactly? The agent harness is the complete architectural system and operational runtime that wraps right around that large language model. The harness provides all those missing faculties we were just talking about. It handles the tool execution, the memory management, the guardrails, and the observability. If your model is a reasoner, the harness is the rigid structure that gives that reasoning a place to actually act, remember, check its own results, and follow strict rules. It literally takes raw cognitive potential and converts it into verifiable, real-world utility.
I love this analogy because it hits the nail on the head. Think about where the term actually comes from. A horse. A horse has immense raw power, but without reins, a saddle, and blinders, it might just run in any random direction or get spooked. A harness doesn't make the horse stronger. It makes that strength reliably convert into useful work. The model is the horse, providing the cognitive energy, and the harness provides the utility to actually pull the carriage.
Let's compare the two directly. The model is the brain. It relies on probabilistic reasoning, it predicts next actions, but it has no memory and absolutely no hands to interact with the world. The harness is the body. It relies on deterministic execution. It manages the tools, it saves the state of the task, and it enforces strict safety rules. Actually, a really good way to think about this is like a computer CPU needing an operating system. A CPU is just a hot rock without an OS to manage memory allocation and handle inputs and outputs. In this paradigm, the model is your CPU and the harness is the OS.
Moving right along to Section 3, Framework versus Agent Harness. Let's look at the tri-layer architecture to see exactly where this sits in your software stack.
If you're building an AI system today, you are essentially dealing with a tri-layer stack. First up, the framework. Things like LangChain, AutoGen, or CrewAI. Developers use these to configure the agent's logic and routing. Next layer down is the runtime. Tools like LangGraph or Temporal. These operationalize that logic by managing the execution and retries. And finally, you have the harness layer, like Deep Agents or Databricks OmniGen. The harness wraps around the framework and the runtime to validate it, adding all those pre-wired guardrails you absolutely need for safe production environments.
The easiest way to wrap your head around this is a commercial kitchen metaphor. An agent framework? That's like a set of raw kitchen ingredients and tools. Super flexible, really fast for prototypes, but it's totally DIY. You've got to install the plumbing yourself. An agent harness, on the other hand, is a fully set up, ready-to-go commercial kitchen. The integrations are pre-wired, the deployment layers are already there, and it is purpose-built for production reliability. You still have to cook the meal, obviously, but you don't have to install the stove first.
All right, Section 4, the 6 architectural layers. Let's dissect the actual anatomy of a harness to see how it governs the AI.
Every solid production harness is built on these 6 concrete layers. 1. The loop, the core cycle of observing, deciding, acting, and verifying.
2. The tools, literally giving the AI hands to read files, run code, or hit APIs. 3. Context, preventing information overload with tight memory control. 4. Persistence, keeping the state across sessions, so if something crashes, you don't lose all your progress. 5. Verification, the self-checks and automated tests. And 6. Constraints, the absolute, hard boundaries detailing what the AI cannot do under any circumstances.
Now, depending on your industry, this architecture adapts and looks completely different. In software development, your harness is using tools like Bash and Git, right? It relies heavily on Docker sandboxing and incremental state persistence, so it doesn't accidentally wreck a massive codebase. But over in finance, the harness is using SQL and ERP connectors, and the unique requirement is massively focused on PII redaction and immutable audit trails. Or take cybersecurity, they use attack case generators for automated jailbreak probing. The crazy part is, the raw model inside might be exactly the same across all three, but the harness is what adapts the environment to those strict domain requirements.
Which brings us to a massive point: safety and verification. The cardinal rule of harness engineering is that the model cannot be the final judge of its own work. Remember, it's probabilistic. It will confidently tell you a broken script works perfectly. That is exactly why the harness relies on deterministic sensors, code linters, syntax checkers, automated unit test suites, and context compaction algorithms to keep the memory clean. And crucially, it uses human-in-the-loop, or HITL, approval gates. If the agent tries something high-risk, like say dropping your entire production database, the harness instantly pauses the execution and routes a request to a real human manager for review. Sandboxed environments ensure the blast radius stays at 0.
Finally, Section 5, the future of autonomy. Let's talk about harness engineering and why this changes everything. Because baseline foundation models are becoming so standardized and so highly capable now, the real differentiator between a wild success and a massive failure is no longer just how cleverly you word your prompt. The frontier has officially shifted to harness engineering. The focus is entirely on actively designing that information environment, optimizing the telemetry, the sandboxes, the verification stack, and the memory structures that the model relies on to do its job. And here is a staggering realization hitting the industry right now. 99% of the practical performance gains in contemporary AI systems are found in the harness, not the raw model. The gap between raw models is shrinking every day, but the exact same model running under different harnesses, they perform like two completely different species. Analysts are estimating that by the end of 2026, 40% of enterprise applications are going to feature task-specific AI agents. The framework activates the model's potential for sure, but it's the harness that dictates how much of that potential actually survives contact with the real world.
To really sum up the ultimate business payoff here, Adi Osmani over at Google put it perfectly. He said, a decent model with a great harness outperforms a great model with a poor one. That's the secret right there. Harness design alone can create up to a 6x performance variation on the exact same underlying model. You could literally take last year's LLM, wrap it in an expertly engineered harness with rigorous verification loops and persistent state, and it will run absolute circles around a state-of-the-art model that was just thrown into production without a safety net.
So I want to leave you with this final provocative thought. When your AI workflows fail, or stumble, or hallucinate, what's your very first instinct? Most of us try to upgrade the model, right? Or we write a slightly longer, more desperate prompt. But the fastest leaps in performance don't come from passively forcing the brain to be better. They come from actively engineering the environment around it. So the next time you're designing an autonomous system, ask yourself, are you upgrading the brain or are you upgrading the environment? Thanks for joining us for this explainer, and we will catch you in the next one.